Welcome all to the next lab session of Analysis and Design of Algorithms Lab. Myself, Mrs. Madhu Nagraj, Assistant Professor, Department of CSE Data Science, ATME College of Engineering, Mysore. The next program is Program 4, that is, program in C to find the shortest path from a given vertex in a weighted connected graph to other vertices using Dijitra's algorithm. That is, we have to find the shortest distance from a single source to all other nodes in the given graph. So before going into the program, let's understand what is this Dijitra's algorithm. So Dijitra's algorithm is a popular algorithm which is mainly used for solving the problem where we have to find the shortest path from a single source node to the other nodes in the given graph. So here we will be having the non-weighted, non-negative edge weighted in the graphs. That is, we have to have only the non-negative values for the weights or the distance. So it cannot have any of the negative values. And it is mainly used to find the shortest distance between two vertices in the given graph. So this Dijitra's algorithm can work on both the directed graph and the undirected graph, as this algorithm mainly concentrates on the distance between the 2 points. But the main thing which we have to concentrate is it should be having all the non-negative values as the weight on the distance between the two nodes. Now, what is the need for the Dijitra's algorithm? So the need for this algorithm is mainly used in the applications where it is used for finding the shortest path between the 2 points is very much important. The best example which we can take is, so whenever we are finding the distance or the shortest path between the two nodes in the maps, that is from the source to the destination, in such a situation, this algorithm is best suited to find the shortest path between the source and the destination. Now, how this algorithm for this Dijitra's works. So first point is we have to mark the source node with a current distance of 0 and all other remaining nodes will be marked as infinity. Now we have to visit one node after the other node for all the non-visited nodes. So from the source node, so when we compare all other nodes, so whichever is having the smallest value as the distance, so next we will be visiting that particular node. And it continues until it reaches all of the nodes in the graph. Now, once the node is visited, so we are going to mark that node as 1 and then the step 2 will be continued. So whenever we are calculating the shortest path, so the one condition which we have to consider is if distance of u plus the cost of uv is less than distance of v, then the distance of v will be equal to distance of u plus cost of uv. So u means the starting of the vertex, the starting of the edge, and v means the end of the edge. That is, if the distance and the cost of that particular edge is lesser than the distance of the second node, then what we are going to do is we are going to update the distance of the second node with the value of distance u plus cost of u and v. So this is the condition. So let's understand this with an example. So here we have a graph. So this is a directed graph, directed weighted graph. So we have 6 nodes. So this is the source node 1. So initially its value will be 0 and all other values are set to infinity. So as we have already seen in the algorithm, so the remaining distance will be set to infinity. So these are the weights on the edges which are given from one node to the other node. So now each and every time when we visit a node, so the distance will be updated on the V vertex or the V node. So this is U node and this is the V node when we consider this edge from 1 to 2. So starting point will be the U and the ending point will be V. So distance of UV, so that is 2. So the cost is now initially infinity. So now let's start. So first we have to consider the source node 1. So we can take any of the nodes. So we can take the node. So now I'm taking the node as 1. So that is the source node. So initially its value is 0. So now from 1, I can visit either 2 or 3, but the minimum value is 2. So directly we can add it. So 0 plus 2. So now it will become, so instead of infinity, the value will become to 2. Similarly, 0 plus 4. So it is 4 is lesser than infinity. So the value infinity will be removed and it will be updated with the value 4. So now I have two nodes to be visited, that is 2 and 3. So now which one to visit? The value 2 is lesser than the value 4. So the next node which we will be visiting is the node 2. So from 2, I have the path to 4 as well as to 3. So now how to update it? So this is distance of u, this is cost of uv, and this is distance of v. So now we have to compare the value whether distance of u, cost of uv is lesser than the distance of v. If it is so, then update the value. So now 2 plus 7, it is 9, which is lesser than infinity. So the value infinity will be taken and it will be updated with the value 9. Similarly, 2 plus 1 is 3. So 3 is lesser than 4. So 4 will be removed and it will be updated with the value 3. So now this node is visited. Next, I have the nodes 4 and 3. So among that, 3 is having the lesser value. So the next node which we will be visiting is 3. So from 3, I have only one path, that is to 5. So 3 plus 3 is 6, which is lesser than infinity. So the value will be updated with 6. Now the next node is 4 and 5. So among that, 6 is having the lesser value. So the next node which we will be visiting is node 5. So from 5, I have two paths, that is from 5 to 6 and 5 to 4. So one path is missing. So one arrow is missing. So I'll just update it. So here, this is the directed graph. So from 5 to 4 and 5 to 6, I have two paths. So 6 plus 5 is 11. So 11 is less than infinity. So it will be updated to 11. Similarly, 6 plus 2 is 8. So 8 is lesser than 9. So that will be updated with 8. Okay. So now the next node we will be visiting is node 4, which is having the lesser value 8 when compared to 6. That is 11. So next, I have only one path from 4. 8 plus 1 is 9. So 9 is lesser than 11. So it will be updated with 9. So like this, we are updating each and every value of the nodes as and when we visit the node. So now we have got the shortest path from source node 1 to all other nodes in the given graph. So from source node 1 to 2, we have the distance 2. And from 1 to 3, we have 2 plus 1, that is 3. 1 to 4, we have 8. And 1 to 5, we have 6. And 1 to 6, we have 9. So these are the values which are updated by using the Digitras algorithm. Now let's see how it is implemented using the C program. So this is the program which is mainly used to implement the Digitras algorithm. So starting we have the nodes which are the variables which are declared. So let's start with the main program. So int main, so we have the different variables n, v, I, j, cost and the distance array, which is mainly used to calculate the cost and the distance. Enter the number of nodes. So you are going to enter how many nodes are there in the graph. Next, enter the cost matrix. So you are going to enter the cost matrix for the given graph. So based on the weights, so the given weight, so we are going to update the cost matrix. Next, the loop will run from I to 1 to n. So we are going to read the cost matrix, cost of ij. Next, if cost of ij is equal to 0, then cost of ij is equal to 999. So we are going to check if at all there is any value of 0 in the cost matrix. And if it is there as 0, then we are going to update it as 999, which means it is an infinity value. So we are making these changes because if there is any 0 value in the adjacency matrix, then it is going to consider that as the shortest distance. So we are going to change it to infinity. Next, enter the source node. So we have to enter which is the source node from which you want to find out the shortest distance. So in our case, which we considered just now, so in that example 1, so you're going to enter the source node as 1. Next, we are going to call the function the Digitras function or the Digitras method, which is this method. So Digitras, so we are going to pass n, the number of nodes, and v, so the edge, the value, which is where you have to read it. Next, cost, so what is the cost from one node to the other node? And next, distance, so what is the distance which we read from each of the nodes? So for that, we are going to use this particular array. So you have the variables IU, count, W, flag, and minimum. So flag is mainly used to check whether the particular node is visited or not. So if it is visited, the flag will be set to 1. If it is not visited, it will be set to 0. Next, for I is equal to 1, I less than or equal to n, I plus plus. So initially we are going to set the flag value as 0 for all of the nodes. So initially, because none of the nodes will be visited, so all the nodes will be set to 0. And whatever the cost of Vi is there, so we are going to assign the same value to distance of I. Count is equal to 2. So the count is set to 2 because the first node is the source node. So we are going to start with the next one. So it is set to 2. Next, the loop runs from count to 2, that is from 2 to the number of nodes, how many nodes are present. So the loop will run from that many number of nodes, that many number of times. So initially set minimum value to 99, that is we can add 999. So that is the infinity value. So initially set it to 999. Next, the loop will run from 1 to n. That is how many number of nodes are there. So till that many number of times the loop will run. So next we are checking the condition. If distance of W is less than minimum and the flag of not of flag of W. That means if it is less than minimum and it is not visited, then we are going to update the value of the distance to the minimum value, and the same value we are going to copy it to U. And then you are going to set the flag to 1. That means now that particular node is visited. So we are going to set the value as 1. Next, the count will be incremented. So each time, whenever the flag is set to 1, that means whenever the node is visited, then we are going to set the value of the flag to 1 and we are going to increment the value of the count. So this is the main condition which we are going to find the shortest distance in the Digitras algorithm. So as we have checked in the as we have checked in the graph, so this is the condition. If distance of U plus cost of U, W, is less than distance of W, so we can take W or V. So both are same. You can take any variable. So in the example, we considered V, but here we are taken as W. So both are same. So distance of U plus cost of UW is less than distance of W and not of flag W. That means if it is not visited and the value is lesser than these two combined values, then we are going to update the value of the distance of W with distance of W is equal to distance of U plus cost of U and W. That is the value, whatever the cost is there between the two edge and the distance. So we are going to update that particular value. And finally, after updating it, we are going to print the value as the shortest path. And you're going to print from which node to which node, what is the cost. So that is V to I and then the distance of I. So whatever the value is there, so we are going to print that particular value. Now let's run and see the program. So how many number of nodes? So let's consider the same example. So we have 6 nodes. So we are going to update the same value. So the number of nodes is 6. Now enter the cost matrix. So you have to enter the cost matrix. So initially 1 to 1 will be 0. 1 to 2 is 2. 1 to 3 is 4, and 1 to 4 is 0, 1 to 5 is 0, and 1 to 6 is 0. Next, 2 to 1, 2 to 1 is 0. Next, 2 to 2 is 0. 2 to 3, we have 1. 2 to 4, we have 7. 2 to 5, we have 0. And 2 to 6, we have 0. Similarly, from 3 to 1, we have 0. 3 to 2, we have 0. 3 to 3 is 0. 3 to 4 is 0. And 3 to 5, there is only one edge, that is 3. And 3 to 6 is 0. Next, 4 to 1 is 0. 4 to 2 is 0. 4 to 3 is 0. 4 to 5 is 0. 4 to 4 is 0. And 4 to 5 is 0. And 4 to 6, we have only one edge of weight 1. Next, 5 to 1 is 0. 5 to 2 is 0. 5 to 3 is 0. 5 to 4, we have one path of weight 2. And 5 to 5 is 0. And 5 to 6, we have one more path of weight 5. And from 6, we don't have any of the edge. So all the values will be 0. So it's asking to enter the source node. So enter the source node as 1. So here you can see what are the minimum path, that is 2, 3, 8, 6, and 9. So the same values which we got when we solved the problem. So the same values we are getting here when you execute the program. So this is how we are going to implement the Digitra's algorithm in order to find the shortest path from a single source node. Thank you.